This is the final video on P7 equations. The two topics we're going to be talking about are absolute values and equations involving absolute values and radicals. So my question is, what does the following statement mean? The absolute value of x equals 3. What kinds of values could we have for x? Well, x could surely equal 3. That'll work for us. Is there anything else that x could equal? So this is the same as x equals 3 or x equals minus 3. Now, one way we can think about an absolute value is, in this case, imagine that line is straight. Here's 0. The statement, the absolute value of x equals 3, is kind of like asking, for what values of x are you 3 units away from 0? So I could go to the right, 1, 2, 3. There I'm 3 units away from 0. So that's where my x equals 3 comes from. But I could also move to the left. So 1, 2, 3, placing me at minus 3, which is where x equals minus 3 comes from. Okay. So we want to find the solution set for the following equation. Now when we say the absolute value of this object equals 9, now by object I mean whatever is inside the absolute values, is equal to 9, what we mean is whatever's inside the absolute value, so 3 times 2x minus 1 equals 9, or 3 times 2x minus 1 equals minus 9. So whenever we have absolute value equations, we're going to want to split this up eventually into two equations and then solve each of these equations themselves. So solving the one on the left, I get 2x minus 1 equals 3. 2x equals 4, that's a 2. X equals 2, or solve the second one. 2x minus 1 equals minus 3. 2x equals minus 2, x equals minus 1. With these two solutions, we need to read the instructions and remember the solution set for x is squiggly bracket 2 comma minus 1. Need a minus there. Okay, good. So next up, we want to solve the following equation. Now we might be tempted to write this, kind of take a leap of faith and write this equation as 1/4 4 times x plus 2 minus 3 equals minus 2. Similarly, 1/4 4 times x plus 2 minus 3 equals positive 2. Writing it once with the number and once with the negative of that number. But we would run into problems with this because what we need to do first is we need to isolate this absolute value and whatever's in the absolute values. So the first thing I want to do is add 3 to both sides. So I'm going to come over here and I'm going to write 1/4 absolute value 4 times x plus 2 parentheses absolute value equals 1. And I'm going to multiply both sides by 4 here also, leaving me with absolute value of 4 times x plus 2, absolute value equals 4. Once I've done this, once I've isolated the absolute value and what's inside it, now I want to split this equation into the two parts. One, rewriting it as it is without the absolute value, so 4 times x plus 2 equals 4. And once, leaving what's inside the absolute value the same, but changing the sign of the number outside. So solve each of these. X plus 2 equals 1, x equals minus 1. X plus 2 equals minus 1, x equals minus 3. And our solution is x equals minus 1 or minus 3. Something to think about. What if you run into an equation that says the absolute value of x is less than or equal to, not less than or equal to, absolute value of x equals minus 2. What would you say about the solution set for that equation? Now we're into the last part of equations, radical equations, and we want to find the solution set for the following equation. I want to ask you a question. When we had an equation, quadratic, that looked like x squared equaled 25, what we did is we used our square root property, right? And added our plus or minus. So if we had a squared, one of the ways we could get rid of that was taking the square root of both sides. So if I have a square root, how would I get rid of that? Well, what I want to do is square both sides. So I'm just rewriting the problem. Square root of x minus 4 equals 5. I want to be sure to put everything in parentheses on both sides because it could hurt me if I don't. Then I want to square both sides. So my square root and my square kind of go away. I get x minus 4 equals 5 squared is 25, and x equals 29. One thing kind of particular to radical equations or equations involving radicals is you absolutely must check your answers. When we square both sides of an equation, it could introduce what are called extraneous solutions. So whenever you're dealing with radical equations, you need to check your answers. So let's do that. Square root 29 minus 4 equals 5. Square root 25 equals 5. 5 equals 5. This is a true statement, so we are good. Coming back to our instructions, the solution set for x is 29. So another equation involving radicals. We want to solve the equation x minus square root 2x plus 5 equals 5. Now we know that at some point we want to square both sides of this equation, and we could do it now, but what you're going to find out is that doesn't actually get rid of the radical for us, which is what's causing us problems. So in that case, what we want to try and do is isolate the square root term, meaning get the square root term by itself and everything else on the other side of the equals. So multiple ways to do this. I'm going to write this as minus square root 2x plus 5 equals 5 minus x. And I'm going to go ahead and get rid of that negative and write this as 2x square root 2x plus 5 equals x minus 5. Okay? Now that I've isolated the square root, I'm going to square both sides. Remember, put it in parentheses before you square it. And the square root and this square go away, leaving me with 2x plus 5 equals x squared minus 25. Did I do that right? No, I did not. Because what I did is what we talked about before, the freshman's dream. I need to be sure to FOIL out the right-hand side. When I do that, I get x squared minus 5x minus 5x plus 25. 2x plus 5 equals x squared minus 10x plus 25. And this puts us into a world where we know what to do. This would put us into quadratic equations. So let's use one of our methods that we learned to solve quadratic equations. And even before that, we need to get all the x's, we need to get everything on one side and set it equal to 0. So doing that, we're going to get 0 equals x squared minus 12x minus 20. And we want to try and factor this, I guess is what I'm thinking. This is also in a suitable form if we wanted to use the quadratic formula, where a would be 1, b would be minus 12, and c would be 20. But I think it's fair for us to factor this way. Since there's a 1 as the leading coefficient, we want, let's see, minus 10. Nope, that's not going to work. It actually will work because I forgot that this is a positive. So I want to do x minus 10 and x minus 2. Solving this, I get x equals 10 and x equals 2. Again, this is a radical equation, so I need to double check both of these answers. And I always want to go back to the original equation to check. So 10 minus square root 2 times 10 plus 5 equals 5. 10 minus 5 equals 5. Good, that one works. 2 minus, so this is my check for 5. 2 minus square root 4 plus 5 equals 5, minus 1 equals 5. No, not true. So I know that 2 is not a part of the solution for this equation, and x equals 10 is my final answer. Like the last video, I'm going to leave you with a bit of a more challenging problem. So here's another equation involving radicals. You have x plus 8, square x plus 8 minus square x minus 4 equals 2. I want you to try and solve this equation. My hint for you is that you're going to have to square both sides more than once.